A ladder leans against a vertical wall, making an angle whose cosine is 0.6 with the ground. The distance between the foot of the ladder and the base of the wall is 1.2 meter. Calculate the height of the ladder. Okay, let's first interpret the question into diagram. A ladder lays against a vertical wall. So let's say this is the wall and this is the ladder. You get it? This is the wall and this is the ladder. Okay, the ladder makes an angle whose cosine means cos. Okay, the ladder makes an angle whose cosine is 0.6. So we don't know the angle, right? But we are given the cosine of the angle. Do you understand? So let us represent the angle that the ladder makes with the horizontal level as theta. You understand? So, but now cos theta will now be what? 0.6. Do you get it? Because we are told that the ladder makes an angle which cosine is equal to 0.6 with the ground. Okay, so the ground is the horizontal level, by the way, so don't be confused. The distance between the foot of the ladder and the base of the wall is 1.2. So this is the foot of the ladder, you know, this is the base of the wall. The distance between these points is what? 1.2 meter. Do you get it? Okay, calculate the length of the ladder. The length of the ladder is length here. We are looking for this length. So how do we calculate this length with respect to the information that we're given? Well, to do that, we first need to determine the angle that we have here. And since cos theta equals to 0.6, that means that theta will be equals to the cos inverse of what? 0.6. Do you understand? Okay. If this is theta, this is what? Opposite. And this is adjacent. This is what? Hypotenuse. So, what is the cos inverse of 0.6? Theta equals to 53.1. 53.1. Let's put it like that. 53.1 degree. Even listen to me carefully. You might not need to determine the value of theta. Are you getting it? Just calculate your answer like that, because we are still going to make use of theta. You see, this is the adjacent and we are looking for the hypotenuse. The trigonometric ratio that is suitable is what? Is cos. You understand? So there is no need to find the value of theta since it is the hypotenuse that we're looking for. But let's say you are looking for opposite. You understand? You are going to make use of tan, you know. If you're looking for the opposite and you've been given the adjacent, you're going to make use of tan. So that necessitates you finding the value of theta. But with respect to what we have to calculate, you don't need the value of theta. I just did that so as to help you to understand, okay? So now cos theta equals to adjacent, which is 1.2 meter, all over hypotenuse, which is x meter, okay? Or x. Cos theta is 0.6. 0.6 equals to 1.2 meter all over x. X is equals to 1.2 meter divided by 0.6. X is equals to 1.2. 1.2 divided by 0.6. That is, sorry, that is even 2.0 meter. Okay, now let's say you are asked to calculate the height of the ladder. If you are asked to calculate the height of the ladder, you cannot go this way. Tan theta equals to opposite. Opposite is the height of the ladder, you know. So the opposite, let us represent as y. Y all over adjacent, which is what? 1.2 meter. Okay. Now theta is what? 53.1. So I'm going to have tan 53.1 equals to y all over 1.2 meter. Is that not it? So to get the value of y, you can just multiply. Y equals to 1.2 tan 53.1. Okay. Y equals to, okay, tan 53.1. I'm coming. Tan 53.1. That is 1.33. So I'm going to have 1.2 multiplied by 1.33. So y equals to 1.2 times 1.33. 1.596. 1.596. Y equals to 1.6 meter. Do you understand? Okay, so that is the solution to that question. I'm very sure you understood all the solution. Like, if you come across this kind of question in exam, you'll be able to solve it. Okay, so let's stop here for angle of elevation. Are you getting it? Let's proceed to angle of depression.
To watch the complete class, kindly click on the link in the description of this video or the comment section. Okay, see you in the next class.